serious. Okay, a sinusoidal function is any periodic function. So we're going to talk about what periodic means in a second. Any periodic function whose graph has the same shape as y equals sine x. Now, in order to graph this, we have to be in radian mode in our calculator. And so we're going to learn how to do that, what radian mode is today, what radians are, and compared to degrees. So it's another way to measure angles. You're used to degrees. It's the most common way we measure angles. But in mathematics, the best way, Rachel, is radians. Okay? So the equation can be either one of two forms that we're going to look at. A sine b times x minus c plus d, or a cos b x minus c plus d. Okay, so those are the two functions we're going to study. What does the a value do to the graph? What does the b value do to the graph? What does the c value do to the graph, and d? So we're going to talk about things like amplitude. Have you ever heard that term before? Okay. We're going to talk about something called phase shifts. We move the graph left and right. We're going to talk about the period of a function. So how long until it repeats itself. So a sine graph, if you were to take a circle, okay, and say you started here, this is usually our 0 degrees, right? And we move around, and we're graphing height over time. So if I was to graph this exact same function, I'm starting at 0. As I move up the graph, my height increases. Then we reach a maximum height. So this is over time. And we get back down to the original height we left at, down over here, once we get to here. Then we're going to go below our original height, and then back to where we started. And so a sinusoidal function would look like, and then it would just repeat itself, and so forth. So that's what a sinusoidal function looks like, something along those lines. It's periodic in nature. What does periodic mean? It repeats, yeah, annually periodic, right? So it repeats. So periodic is a function that repeats itself. It's periodic. So it's going to repeat itself. So that's pretty cool, hey? So graphing the height of your circle over time. That's what a sine graph looks like. So we're going to need rulers here. So we're going to go through our activity now. I'm just going to pause the video for a second so I can hand out some stuff. Record. My radius is the length of my pipe cleaner. So what you want to do now is I want you to take your pipe cleaner, and the reason why we're using pipe cleaner is it bends, right? And we want to start at A and go along your circumference and mark the letter P. So take this, bend it nicely, and mark the letter P. So it should be 5 centimeters. This curve here should be exactly 5 centimeters. Okay, do your best. If you drew it by hand, it might be a little off. Okay, and then what I want you to do is connect the line here. Well, that's supposed to be letter P. Okay, connect that line. So how far is that line as well? 5 centimeters. It should be, because we've measured out 5 centimeters on our pipe cleaner, right? This length here is 5. This, no, it is. It is the same. Okay? Mathematically, it's right. Now, what I would like you to do is measure the angle in degrees. They're coming. The angle in degrees this and this angle is. Okay? Nope. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, does everyone have one? Yeah, I guess, but yeah, I guess. Is it the same?
No, my bad. It's perfect.
Oh my gosh! So you can double check your circle. Double check your circle now. Well, good to know for next year. Leah, that's no good. Okay. So, I'm going to grab my protractor. I don't know if you've seen this before. Boom, boom. Okay, so approximately how many degrees is it?
Close to 50, right?
No.
60.
Close to 60, not quite.
62.
Look at it. How do we measure an angle, guys? Line up the, yeah.
I got 58.
57. In fact, you should be exactly 57.3-ish.
I found that. Mine too. Mine's really close to that.
Okay, it should be 57.3 degrees. Okay?
Come here and look at it. Look how good I did it.
Yeah, it's perfect. Yeah. See? Okay, so are you ready for why did we just do this? Well, let me tell you why. This is equal to 1 radian. Okay, so 57.3 degrees is approximately equal to 1 radian. And so a radian is another way we measure angles. Okay? So, by definition, a radian is, if we can go to the next page, a radian is when our radius and our arc length are the same length. That angle it makes is 1 radian. So this would be 1 rad. Okay? So, guys, this is called, PA is called an arc length. An arc length. And it actually has like you can see an arc over it when we write it properly. So we're on the next page. Okay? Your pipe cleaners you may keep. Actually, no, I better keep them. Yeah, because I need to use them next year. Do you really want to keep your pipe cleaners?
Yeah.
Oh, okay. Okay. But if you're not paying attention, I can take away your pipe cleaner. Okay. Okay, so by definition, 1 radian okay. Guys, Jesse. So 1 radian is when, or is the angle, actually we should say, is the angle when CA equals PA, arc PA. So our radius is equal to our arc length. No matter how big our circle or how small, that's 1 radian. When our arc length equals our... It's a good estimate. It's going to be about 6.28. Yeah, 6.28. Okay, so we did this. So with a protractor, we measured our angle to be approximately 57 degrees, or 57.3. What is the measure of 50? Okay, so we did that. So how many, I want you to grab your pipe cleaners. Again, you still need them. Sorry if you've messed it up. And I want you to see how many times you can go around. How many times can you go around? Kind of gave it to you already. Did you? Okay, So if you take your pipe cleaner, you go around. So this is my 1, and then go switch around. Go. This is 2, 3, 4, 5. You should get 6.2 times. You can go around about. So in 360 degrees, guys, it's 6.2 radians, approximately. Rads. We use the unit rad.
What's a unit?
This means approximately equal to. It means approx. The circumference C of a circle is given by the formula 2 pi r, where r represents the radius. Explain how this formula relates to your answer in C. So if we rearrange the formula to get 2 pi by itself, we get circumference over our radius. And so if we take our full circumference divided by our radius, that is equal to how many radians we have in our circle. So this would be, if you type this into your calculator, what is it equal to? Type that in, 2 pi. Do you know there's a pi symbol on your calculator? Of course there is. Second hat is the pi symbol. And it's right above the division. Okay, that equals 6.28. So that's how many radians are in a full circle. So 2 pi in your circumference of your circle is equivalent to 360 degrees. So 2 pi radians is exactly 360 degrees. Exactly. Okay, so what does that mean? Well, if we reduce that, how much does 1 pi equal? If 2 pi's, it's 180. So pi radians, how much is pi? Approximately 3.14 radians is equivalent to 180 degrees. Yeah. Okay, so we're going to do some estimating. If you turn the page over. So benchmarks, you should know that 1 radian is equal to approximately 57.3 degrees. Okay, that's what we're going to use to estimate how many radians there are in something. We know that pi is equivalent to 180 and 2 pi is equivalent to 360. So we're going to start with estimation, and then we're going to work with actually converting degrees to radians today. So, and this is just same stuff. Okay, so if I want to estimate how many degrees or how many radians 90 degrees is, Dean, this is what I mean. You lose your pipe cleaner.
No, please.
You'll get it back later.
He's like a man. It was gonna be sticky.
I'm sure it was. Okay.
He's a full-grown adult. Take this pipe cleaner.
Yeah. He's not a full-grown adult.
Legally, I am.
Legally, maybe. but. Okay, so easiest way to estimate how many radians something has is divide by our approximation. So 90 divided by 57.3 gives us approximately 1.57 radians. Okay, so what would be the next one? Find out the next one. Yeah, we're going to use 57.3, a little bit more accurate. Yeah? So how many radians approximately is that? 2.1? Do we agree?
Yes.
Okay, 2.1 radians. Rad. Okay? That's the easiest way to estimate. Do we need to do this again? Let's see here. Do you get those ones, example 1 and 2? A little note about 450 degrees. If I were to draw 450 degrees, how would we draw 450 degrees? Does anyone know? You go all the way around, and then you stop. So how much more would I have to go after the 360? 90, because 450 minus 360 is 90 degrees. So then if we were to draw this, we always start here when we draw our angles, and we're going to move in a counterclockwise direction. So this would be once, so that's 360, and then to 90 here. So that would be 450 degrees. Did you do that before? Some of you did, some of you haven't. Depends on which math course you came from. Okay, so let's just write, let's draw this here. This is 0, 90 degrees is here, 180, 270. This is also 360. And so 90 would also be 450. All right? So how do we actually convert between radians and degrees? Well, the easiest way to find the exact value, don't be cutting your hair, is to use this ratio. We know that 1 pi is 180 degrees, exactly. So this is super important, guys. This is not going to be given to you on a formula sheet. You need to know this. So if we're changing degrees to radians, guys, we're going to multiply by pi over 180. Sawyer? If we're converting radians to degrees, we're going to multiply by 180 over pi. So whatever we're looking for goes on the top. If I'm looking for radians, then pi will be on the numerator. Okay. Yeah, sure.
No.
I know, it is perfect.
I'm actually a little hot.
We're going to get warmer. So let me show you what I mean. So to convert 30 degrees to radians as an exact value, not as an estimate, we're going to multiply by pi over 180. Why? Because we want radians, so radians on the numerator. We want degrees to cancel out on the denominator. In my calculator, because I want to leave this as an exact value, if I want to leave this as an exact value, what button do I not want to put in here? Or what do I not want to put in? Does anyone? No. Pi. Pi is a rational number, right? So we want to leave it in terms of pi. So all we're going to enter is 30 divided by 180. Okay? So that it's in terms of pi. And then change it, math, enter, enter. So that is equal to 1/6 pi, or pi over 6 as an exact value. If we only wanted the decimal version, then we can literally just type in 30 times pi over 180. And that's the same thing as pi over 6. Same thing. Okay? So this guy, who do we want to, what is he right now? Radians or degrees? Yeah, if there's no degree symbol, it's radian. So this is radians. So I want to convert it to degrees. So we're going to multiply by what? 180 over pi. So I want degrees, so this time we're going to multiply by 180 over pi. What's going to cancel out? The pi's. So we only need to type in 2/3 times 180. Exactly 120 degrees. Okay, the next guy, what is he right now? You can get it back later. You can get it back later, sir.
Oh, it's fine.
Sawyer. Seriously, how old are you? You can get it better later. Okay, so this is degrees. What do we multiply by if I want to change it to radians? Pi over 180. What are we going to put in our calculator? 210 divided by the 180, and then Math, enter, enter. So to reduce the fraction. So this is 7 pi over 6. 7 pi over 6. Okay, last guy. We want to convert him to what? Degrees. So times by 180 over pi. So degrees on top if you're looking for degrees. What cancels? Pi. And so what are you going to type in? 9 over 5 times 180 is 324. Okay? You don't need it right now. So your homework, you have 2 things for homework. Okay? One is in your workbook, and which will take you no time at all. And the other is a worksheet. And let's say the odd. Yeah, this is part of homework marks. There's an extra one here for Andrew.
Why do you make it so hard, though?
I'm not.
I'm trying to get 6 out of 6s, and it's not going to happen because you won't get an extra homework.
Because the workbook did not cover enough. So yeah, you can return your rulers and your scissors and all that stuff. I'll show you what you don't have to do all of it. Just listen up. You're not going to have to do all of it. Just listen up. 4, 5, 6. Okay, it doesn't start here. So your homework in the workbook is 8.1. So go to page 197. 197. Okay. So 8.1 starts at page 197. And then the worksheet. Now listen up. It's not all of the worksheet. Okay? So the ones I want you to practice.
Be reasonable.
I am going to be reasonable. I promised you this. Okay, the answers are on the second sheet. So all I want you to do on this sheet is all the left columns, none of the rights. So turn all the left columns.
On the first sheet.
It's only two-sided. The other one attaches the answers. So only the first.
I don't see the answers for this.
So these are the answers that are right beside it. Okay? Which one?
What page are you on?
There are answers here.
Oh,
Okay?
okay.
So they're the
left side?
they're only the left side, right? Okay?
On the first page, front and back.
Yeah. If it's a negative, guys, if you have a negative degrees, then your answer will be negative radians. So the first one, if I multiply by 180 over, we want pi, we want radians. Okay. Kathleen, what would I enter in my calculator for the first one? Negative 290 over 180. Math, enter, enter. So your answer would be negative 29 pi over 18. The pi goes on the numerator. So it's just all the left, or the odds. All the odds you have to do, okay, for the worksheet. And then the workbook 8.1, it's really quick. It's just a couple estimating ones. And then drawing, or you might have to measure some angles with your protractor. So you'll need the protractor, for the homework. No, this is a compass, right? This is a compass. You need this for your homework. Yeah, this is a compass. I always mess those two up. That's a protractor. I should know that. It's like a electrician not knowing her tools. I've always mixed the names of those two up. You're going to need a protractor, and I always call compasses protractors